Welcome to our YouTube channel. Hello my dear friends, how are you? Welcome to our YouTube channel ADC Max. In this class, I use one problem, I introduce one problem having two different intervals. In terms of pi. That means that the function can be defined as x in the interval 0 less than x less than pi and 2 pi minus x in the interval pi less than x less than 2 pi. So this is the open interval. Once I repeat this is 0 comma pi, pi comma 2 pi. So this is the open interval. What is the meaning of open interval? This open interval means these points are point of discontinuity. These points are the points of discontinuity. That means that these 2 points are not included. Got it? And apart from that, I would like to generate this series. Sigma n equal to 1 to infinity 1 by 2n minus 1 whole square. What is sigma n equal to 1 to infinity 1 by 2n minus 1 whole square? Yeah, can you substitute n equal to 1? I am getting 1 by 1 square. Putting n equal to 2, we get 2 to the 4, 4 minus 1 is 3, so 1 by 3 square. By putting n equal to 3, we get 6 minus 1 is 5, so 1 by 5 square. So that means that if something is new, it's the sum of the 1 by the squares of the odd numbers, 1 squared, 3 squared, 5 squared, etc. So from this series, I would like to generate this infinite series as well as the sum of this infinite series. Let us see how. Let us see how we are going to get this value. Yeah. As we know that the required Fourier series is y equal to f of x in the interval 0, 2 pi is a naught by 2 plus sigma n equal to 1 to infinity a n cos nx plus b n sin nx. Clear? So this is my required Fourier series number 1. My aim is to get the a naught value, a n value and the b n value. After getting the Fourier series, try to expand this or try to find the value or deduce the value of the sum of the infinite series, right? Now, to find the a naught, as we know, the a naught formula is 1 by pi, the half of the range, integral 0 to 2 pi, f of x dx. Clear? In this problem, the function f of x defined in two subinterval, one for 0 to pi, the function is x. And from pi to 2 pi, the function is 2 pi minus x. Clear? Right. Now is equal. 1 by pi, integral x is x squared by 2 with the limit 0 to pi plus 2 pi minus x integration 2 pi x minus x integration is x squared by 2 with the limit pi to 2 pi. So 1 by pi is common, right? So don't forget the 1 by pi. So 1 by pi into, let us substitute x is equal to pi, I am getting pi squared by 2. What about the lower limit? 0. So just leave it. Okay. Plus the second term, the upper limit is 2 pi. So 2 pi into 2 pi, how much? 2 pi into 2 pi is 4 pi squared, is right? Minus, what about x here? 2 pi whole square is 4 pi squared. By 2 it is 2 pi squared. So this is the upper limit value. Clear? In the second term, the upper limit value is 2 pi into 2 pi is 4 pi squared minus 2 pi whole squared. 4 pi squared by 2 is 2 pi squared. Now let us back to the lower limit pi. Substitute x is equal to pi. Substitute x is equal to pi. 2 pi into pi is 2 pi squared. Minus, once again substitute x equal to pi. I am getting that pi squared by 2. It's clear? So this is the second one. So to simplify this, we get the answer 1 by pi. Pi squared by 2, 4 pi squared minus 2 pi squared. I think 4 pi squared minus 2 pi squared, this is also minus 2 pi squared. Totally what happened? 4 pi squared minus 2 pi squared minus 2 pi squared is minus 4 pi squared. It cancels. So this time it cancels totally. What about minus or minus? Plus pi squared by 2. So pi squared by 2 plus pi squared by 2 is pi squared. After cancellation of 1 pi, I am getting that a naught is equal to pi. So once a naught equal to pi, what about a naught by 2? It is pi by 2. So I am getting the a naught value. So this somewhat is very lengthy one because the function is defined in two subintervals. Right? So a naught is pi. What about the an now? Let's find out the an and the bn. So how to get the an value? So go for the an. What is the an? An is the coefficient of cosine term. So let us find out the an. As we know that the formula for an is 1 by pi integral 0 to 2 pi f of x into cos nx dx. Clear? So now use the function. In this problem the function is defined in two subintervals. So an is equal to 1 by pi integral 0 to pi x into cos nx. And the second interval is pi to 2 pi. In the second interval the function is 2 pi minus x into cos nx dx. Now this looks like the Bernoulli's model. Looks like the Bernoulli model. Let us see that this is the u, this is the v. This is the u, this is the v. So let us use apply the Bernoulli formula 2 times in this step. Let us see that the intervals are different. So please be careful while integrating and as well as by applying the limits. So what is the an? An equal to 1 by pi. 1 by pi is common. So first I would like to use the Bernoulli formula for the first integration. Bernoulli formula for the first integration. U v1 minus u dash v2. Right, sir? Once I repeat this is the first integration for 0 to pi interval. U is x, v is cos nx. So what's up? This looks like u v1 minus u dash v2. Bernoulli formula. Clear? Right? So u x v. The cos nx integration is sin nx by n. Minus, formula minus. Derivative of u is x is 1. Then the integral of sin nx is minus cos nx by n. Only one more n is already there. So we get n square. The same manner, we are going to write the second integral. U 2 pi minus x. Sin nx integration is cos nx by n. Minus, formula minus. 2 pi minus x integration is minus 1. Sin nx integration is minus cos nx by n square. Once again close the bracket and the limits here pi to 2 pi. It's clear? So 1 by pi is common. 1 by pi is common for the whole terms. So you thought this is somewhat very lengthy because here we have 2 terms, here we have 2 terms. When apply the upper limit we get 4 terms, for the lower limit we get 4 terms. So 8 terms. Don't do like that. The simple idea is let us see the terms sin nx cos nx. So before going to apply the limits, let us recollect the values of sin and the cos. What is sin 0? 0. Cos 0? 1. Sin pi? 0. Sin 2n pi? 0. So all sin terms are 0. What about cos n pi? Minus 1 whole power n. What about cos 2n pi? It is plus 1 because 2n is an even number. So once if you recollect all these values, then it's very simple. Now let us look into the term. In this term, what we have seen that sin nx is here. So x is equal to pi, we get sin pi 0, x equal to 0, 0. So we don't bother about this term, so can you omit it? Clear? Similarly, in this term, so by putting x equal to 2 pi, we get sin n pi, and by putting x equal to pi, we get sin n pi. So multiples of pi means you please kindly don't bother about the sign term. So these 2 terms are automatically vanishes. So beyond that, the first one we have only one minus or minus plus 1 by n square. In this case, minus or minus plus, plus and minus minus 1 by n square. I think so 1 by n square is common. So let us take 1 by n square first. So 1 by n square into pi. So the first one I am having only cos nx with the limit 0 to pi. Plus this plus. The second term minus to minus plus, plus to minus minus. 1 by n square taken outside. So this time minus is still there. So can I take the minus n outside? The remaining is cos nx only. But the limits are different. You see the limits are different. Don't cancel these 2 terms. Sorry, it is wrong. Okay, because the limits are different. Now let us substitute. Let us substitute the value of x. If x equal to pi, we get cos n pi. Cos n pi value is minus 1 whole power n. By putting x equal to 0, we get cos 0 is 1. So this is from the first term. The second one, by putting cos nx, in the x we replace by 2n, we get 2 pi, we get this cos 2n pi value, cos 2n pi value is plus 1, so this is 1 minus half. By putting x equal to pi cos n pi is minus 1 whole power n. So I am putting the two terms, but this is 1 minus half minus 1 power n. What about this one? This is also looks the same. Can I rewrite this by minus taking outside? What we will get? So let us see that an is equal to 1 by pi n square. Can I rewrite this by minus half 1 minus half minus 1 whole power n? Can I rewrite this minus sign outside? See that? When I take the minus sign outside, this becomes minus half 1 minus half minus 1 power n. I think there are two similar terms with the minus sign. So this is minus 2 times. So minus 2 times 1 minus half minus 1 whole power n. Once I repeat this step for you, with a better understanding purpose, minus 1 whole power n minus 1. Can we take the minus sign outside? This becomes 1 minus half minus 1 whole power n. So these two are similar with the minus sign. So minus 2 times pi by n squared of 1 minus 1 by n squared. But once the term looks like this, what we are going to that? Let us check it out if n is even or if n is odd. If n is even or odd. If it is odd, what happened this value? If it is odd, what happened this value? This becomes minus 1. So 1 minus half minus 1 becomes plus 2. So 2 into minus 2 is minus 4 by pi n squared. Once again I repeat this. If n is odd, this becomes minus 1. So minus of minus becomes plus 1. So 1 plus 1 is 2. 2 into minus 2 minus 4 by n squared. If n is even, this becomes plus 1. So 1 minus of plus 1 is 0. So the an value is minus 4 by pi n squared if n is odd value. If n is odd value 1 comma 3 comma 5. What it? 1 comma 3 comma 5. Now what about the bn now? What's the bn sir? Yeah, bn. The same manner we are going to find out the bn. Find the bn. As we know that the bn formula is 1 by pi integral 0 to 2 pi f of x. Now bn is the coefficient of sin nx term, so let us include that term sin nx dx. In this problem, the function defined in two subinterval, one is 0 to pi. In 0 to pi the function is x, so x into sin nx. From pi to 2 pi the function is 2 pi minus x into sin nx. So once again, apply the Bernoulli formula. Apply the Bernoulli formula in the place of this is my u, this is my v, this is my u, this is my v. So apply the Bernoulli formula twice the time. Twice the time I am getting that 1 by pi x into minus cos nx by n minus 1 into minus sin nx by n square with the limit 0 to pi. Right? Plus the same idea, let us use the Bernoulli formula 2 pi minus x into minus cos nx by n minus formula minus differentiate the 2 pi minus x with respect to x. I am getting minus 1. So minus sin nx by n square with the limit y to 2 pi. Once again 1 by pi is common. I don't want the sin terms because these terms are obviously become 0. Sin 0 0, sin pi 0, sin 2n pi 0, everything 0. So what are the rest of the term? The rest is minus 1 by n minus 1 by n. So we can take the outside. So minus 1 by pi into n taken outside. The first term we have cos x into cos nx with the limit 0 to pi. This is the plus sign, yes, plus sign. Here already taken minus 1 by n outside. So the rest is 2 pi minus x into cos nx. For this second term the limits are pi to 2 pi. Now let us apply the limits. If you substitute the limit for x is equal to pi, I am doing pi into minus 1 whole power n because cos n pi value is 0. Isn't it? When I substitute x equal to 0, 0 and everything 0, so just we leave it. So first term lower limit value 0, leave the term. What about the second one? This is the second one. What is the upper limit of x? 2 pi. 2 pi minus 2 pi is 0. So the first term lower limit is 0. In the second term the upper limit value is 0. So leave it. Minus The lower limit 2 pi minus pi is pi, cos n pi is minus 1 whole power n. Once again I repeat this. When x equal to pi, pi into cos n pi value minus 1 whole power n. By putting x equal to 0, 0 nothing is 0, so I don't want to write that term. Let us back to the second term. The second one, let us substitute x equal to 2 pi minus 2 pi is 0, 0 nothing is 0. So upper limit is 0 minus lower limit, so minus comes here. Putting x equal to pi, 2 pi minus pi is pi, cos n pi value is minus 1 power n. I think so these two are similar terms, so 0. Bn value is 0. We came to know that once after integrating the values, we may came to know that the values are 0. Is it possible to get before integration? Yes, possible only when suppose they are defined in the interval minus pi comma pi. Then with the help of even and odd functions, we can get the values before doing the integration. Please go and watch my previous videos, even and odd functions. Okay. Now, after getting the a naught, an, bn, now bn is unfortunately 0, an is minus 4 by pi n squared if n is the odd values. Right? Let us substitute the a naught, an, bn. What I am getting that? I am getting into the series. So this is my series. This is my series. What is series? A naught by 2. So what is the a naught? I think so a naught is pi. So pi by 2 plus now an. Please see that an is true or valid only for the odd values. So odd value means 1, 3, 5, 7 up to infinity. What about the even value? 0. Once it's 0, we don't bother about. We won't consider those values, the 0 values. So only non-zero values only consider. So n equal to 1, 3, 5. At that time the an value is minus 4 by pi n squared cos nx. What about the bn value? 0. So this is the required Fourier series. Is the required Fourier series. Is right? Now from this equation number 2, my aim is to generate this series. So how to generate this series? See that? It's very interesting. Let us see the denominators 1, 3, 5. Yeah, let us see the square term. N, the denominator n square. So this term only will generate this series. Square term only. What are the possible values for n? 1, 3, 5. So which gives 1 by 1 squared, 1 by 3 squared, 1 by 5 squared. But at the same time, let us retain the term by choosing some value of x. So what is the function here? It is the function is given in two subinterval. One is 0 to pi, another one is pi to 2 pi. 0, pi, 2 pi, all are point of discontinuity because it's an open interval, isn't it? So we don't consider those 3 points 0, pi and 2 pi. In the interval 0 to pi it is x. In the interval pi to 2 pi the value is 2 pi minus x. So this is the given function. Clear? Now I want to choose x equal to 0. Can we choose x equal to pi by 2? Sorry, if we choose x equal to pi by 2, what about cos pi by 2? 0. Cos 3 pi by 2? 0. Cos 5 pi by 2? 0. Everything is 0, it won't be generated. So better idea, you can choose x equal to 0. Can you choose x equal to pi? We can choose x equal to pi, we get cos n pi. Cos n pi value is minus 1 whole power n. If n is odd, we are getting the minus 1, minus 1, minus 1. That too also the possible way, but let us check it out whether this will generate this required series or not. So I go with the least possible value of x equal to 0. So this is very clear that it is a point of discontinuity. There is a point of discontinuity in the extreme side, in the end side, right? In the extreme side. So by convergence theorem, what I am going to do that? By convergence theorem, the left hand side f of x at x is equal to 0. So where is 0? 0 in the extreme side. So by convergence theorem, adding the two extreme values f of 0 plus f of 2 pi by 2. What is f of 0? 0 lies in this interval. So replace x by 0, we get 0. 2 pi lies in this interval. In this interval the function is 2 pi minus x. So substitute x is equal to 2 pi. So 2 pi minus 2 pi by 2, 0. So 2 pi minus 2 pi is 0. 0 plus 0 by 2 is 0. Now this equation 2 becomes, what about the left hand side? The left hand side is f of x at x is equal to 0. Right hand side, pi by 2, this pi by 2 constant term, and minus taken outside, minus 4 by pi taken outside, is right, minus 4 by pi taken outside. Summation n equal to 1 comma 3 comma 5 to infinity, x equal to 0, cos 0, 1 by n square, right? So this is my required series. Now the left hand side is 0 is equal to pi by 2 minus 4 by pi. Let us substitute n equal to 1, I am getting 1 by 1 square, n equal to 3, you get 1 by 3 square, n equal to 5, you get 1 by 5 square, etc., etc. So this is my required one. Let us fix this in one side, others can be simplified in the next side. So this pi by 2, move on to the next side, becomes minus pi by 2, and this is the product sign, So this is equal to minus 4 by pi of 1 by 1 square plus 1 by 3 square plus 1 by 5 square plus etc., etc. up to infinity. Let us cancel the pi. Let us reciprocating this side, we get it is pi by 2 into pi by 4. So the answer is pi into pi squared by 8. So this is the required sum of the given infinite series, 1 by 1 square plus 1 by 3 square plus 1 by 5 square, etc., etc. So I hope everyone you may understand. That is, please kindly watch the video carefully. Once if you skip any time in this video, you can't able to understand this concept. Thank you for watching our YouTube channel. Support and share our YouTube channel ADC Maths. Thank you, one and all.